Hello everyone. So today we are going to talk about rectifiers. So generally, what do you mean by rectifier? Rectifier is a circuit which convert AC supply into DC. So why we are need to convert AC into DC? Because the DC, which is only the thing we have to get from the battery or some other resources. But the many times DCs are not available for the commercially. So because the AC supply only is available in our home as well as office, so somewhat because the commercial sector they have a AC supply is only provided. So we need to convert in a particular AC into DC. That's a circuit which is essential. That's why we are doing for rectifier circuits. So now we have to deal about the rectifiers in this session. So rectifier is a device or is a circuit which convert AC supply into pulsating DC using a diode. Right here, the diode is the one of the key component which is used to convert AC into DC using one or more number of diode depends on this circuit. So by usage of the circuit, the rectifier circuit, it is going to classify as two types. One will be called as half wave rectifier and other will be called as full wave rectifier. So half wave rectifier means we use as a only one diode, and here the full wave rectifier means we use as a depends on the center tap transformer or the bridge rectifier. So that depends on it, two or more diodes which is going to be considered. So in this video, we have to focus about half wave rectifier circuit. So look at this circuit diagram for the half wave rectifier. So which contain a transformer. Usually we prefer a step down transformer and one number of diode and the load resistor. Why it is called a half wave rectifier? Because the AC input which is going to apply because of one cycle of AC, positive off cycle as well as the negative off cycle. So but the output of the rectifier circuit they permits only positive portion. That means only one half of the portion of the AC will be permitted to that output. That's why that is AC means is what? We have to convert AC into pulsating DC for the output of the half wave rectifier. So that's why we have to conduct during only one half of the AC waveform, and during negative portion of the AC waveform, it will be blocks. So they permit only positive portion of AC inputs. That's why we called it is half wave rectifier. And look at the transformer. Why? Because we are using the transformer in the circuit. Because a transformer used to step down the magnitude of AC. Because of 230 volt is the primary supply. So the 230 volt is need to convert to DC. 230 AC into 230 DC means will not suitable for the electronic circuit because the electronic circuits are low power operating component. That's why we need to step down the magnitude of AC. That's why the transformer ratings is preferred as very important one. So here in this we have to choose for the primarily the transformer as step down transformer. So here in this notation N2 as well as N1, what will be called as N2? N will be called as number of turns of this coil. N2 is the secondary number of turns of the coil, and where N1 is the primary number of coil. And E will be called as induced EMF, which is represented as E suffix SM, which means for secondary maximum value, as well as E suffix PM, which means for primary the winding voltages. So in this actually the AC waveform is going to the input. That's why it's a sinusoidally varying quantity. That's why ES is nothing but ESM sine omega t. Let's see the working of the half-wave rectifier. And during positive off cycle of the AC supply, the terminal A of the transformer winding is become positive with respect to terminal B become negative. So now that the positive supply which is connected to the diode D is getting forward biased, and during the forward bias condition, the diode just like a ideal conductor because it's act as a closed switch, they're allowing a positive portion of the AC input to the load. That's why we have to get across the load resistor the positive of the AC supply will be permitted to the load and it will be completely loop so that the load current flow in a clockwise direction. Now look at the negative half cycle of the AC supply. The terminal A is now negative and terminal B become positive so that the negative supply which is connected to the anode. So the diode D is getting reverse biased. So in that reverse bias operation, the diode is just like a open switch, does not conducted. So that the circuit becomes an open circuit. So there is no current such across the load resistor such that the output across the load is become zero. So it blocks the negative portion to reach to the output. They permit only during the positive of cycle. So which permitted to the positive portion of the supply. That's why we have to call that kind of circuits are called off wave rectifier. Why? Because they are allowing positive AC in waveform to the load and it will be stop the negative portion of the AC waveforms. Now look at these waveforms. Look at that first one. Let us see this. This one is AC input waveform. It's a sinusoidally varying quantity. And look at the figure. It contained during the positive portion of AC input. Look at the positive off cycle. The diode is just like a conductor. So because of diode D getting forward bias and it will be on state, so they are allowing a positive portion of AC current. So that positive portion of AC waveform appear across the load resistor. And you see in the negative portion of AC input, the diode D getting reverse biased and the diode said to be in off condition. So just like the open switch, so it does not allow any current between the junction. So it will be stop the negative portion of the AC waveforms. So they permit only positive portion of the waveform and it will be stop the negative portion of the AC waveform. So out of the one cycle of AC input, they are allowing only positive portion of AC supply and it stop the negative portion of AC supply to reach its low. But the negative supply, the entire negative voltage appear across the junction in the reverse bias condition. You see in the negative off cycle of AC waveform. So that is said to be peak inverse voltage capability of the rectifier. Because this, whatever the magnitude in the same forward bias condition, that means the positive off cycle will same as in the negative off cycle will be appear across the junction under open circuit. So the diode must have an ability to withstand the peak inverse voltage without damaging the diode for their operation. It's very, very essential one. We'll consider it. So that is the capability of the peak inverse voltage rating of the diode. It must be high. Now we can talk about the advantages. It is so simple circuit. We have considered only one number of diode is so sufficient to making the circuit design. So it's quite very easy as well as ordinary transformer is very suitable one for the circuit, not mandatory for the center tap transformer for the circuit. So overall the circuit is so simple and is less compact. Now let us going to discuss about the disadvantages of a rectifier. So the first point, the ripple factor of the half-wave rectifier is 1.21. That means out of percentage, it's a 121 percentage of the ripples which is founded in that output. What do you mean as a ripple? So that the transformer that which will be actually used, why? Because it's a step down purpose because of AC supply we provided to the rectifier inputs. But the output of the rectifier is a DC. So, but the output will not as a pure form of DC, is a pulsating DC. So the amount of some amount of the AC component still founded in the DC output. That's why it is the ratio of AC component to the DC output. So that which is actually is oscillating one. That's why it's too high. That means 121 percentage of the ripples they're founded in the output of the DC supply of the rectifier. And the second very important one, the theoretical efficiency also very poor. So the efficiency rating at the theoretical range is 40% only. So the practical, we consider for the practical rectifier is a little bit comparatively to less than that of the 40%. So it's a poor efficient one. Out of the 60% of the power is wasted, which is called as a ripples. Only 40% of the power is only converted into DC supply. And the transformer circuit has low utilization factor for the transformer because the transformer only effectively operated during positive off cycle of AC supply. And you can see that the negative off cycle, the transformers are will supply the to the diode, but the diode does not permit it to the load. It will be conducted only during positive portion. That's why the transformers are not effectively utilized for the complete AC waveforms. And the DC current will chance to flow to the core. It will be getting saturation of the core may raises a huge problem. So in order to improve, we have to increase the size of the core. But if you want to increase the size of the core, the transformer size is so bigger. The rectifier circuit is also becoming so bigger one. So that you have to minimize the core size means is what in order to maximize the current rating. So that it will be one of the huge drawbacks while considering in this half-wave rectifier. So the overall, the half-wave rectifier is a less preferable choice comparative to the all other type of rectifier. Is only the thing you need to convert AC into DC is if it is sufficient, you may be to choose this one. Or otherwise, if you want to consider about the efficiency point of view as well as the ripple factor point of view, it's not suitable for commercial usage. So I hope in this video for everyone can able to understand the simple working of half-wave rectifier circuit, whether how it is performed during positive upcycle as well as the negative upcycle of the portion of waveform will be the giving the better clarity. We can discuss about the remaining the ripple factor as well as the theoretical efficiency calculation. We'll see the analysis part. I'll give in the next video. Thank you so much.